We're on page 5. Let's take a peek at, let's take a peek at this guy. This is a little warm-up. We definitely did something harder than this on Thursday. But it says, hey, here's F. What's F prime? Does this have an outer and an inner? What would be my outer? Yeah, there's my outer. This guy's my outer. And then this one's my inner. So, what's the derivative of that outer? What are we going to do with that 4? Derivative of the outer? Yeah, move it to the front. What do I do with that inner? Keep it the same. Keep that chocolate. Sine of 2x. And then what does that exponent become? To the third. Then I got to eat that chocolate. Of this. Can I take the derivative of e to the 3x? E to the 3x. Yes. Do I need to multiply that by the derivative of anything else? Yes. Yeah. So, just focusing on this, if we're just looking at this guy, he's got an outer and an inner. I know. But, to Evan's point, you're like, wait, the derivative of e to the a thing is always e to the a thing. I agree. Times the derivative of 3x would get me very good. That's the derivative of e to the 3x. I know it's been 3 days. We just learned the chain rule on Tuesday, so don't you fret, guys. Don't you fret. Whew. Derivative of sine of 2x. Cosine of 2x times the derivative of its inner. 2. That's a lot. Wow, that was a Monday smack you in the face right there. Does that match anything? Let's see, we're thinking C. We got our 4. Let's see if I can add 4. We got e to the 3x, sine of 2x, bring that to the third. Then we have 3 e to the 3x. And my 2? Whew. Is AP going to give you one that long? No. As a multiple choice, no. That was my little warm-up of so many outers and inners. We do need to take the derivative of every little piece, but we can only do one at a time. Okay? Whew. That's a toughie. Let's try this one. I think that this one's a little nicer. Here we go. Let f be e to the h of x. Which of the following is equivalent to the derivative of f? What's the derivative of anything e? E. But what do we need to multiply that by? So we took the derivative of e, we left its inner, and then we got to multiply it by the derivative of that inner. Yep. So that would leave me with h prime of x. Yeah? Okay. So is that an answer? C, yeah. Whew. Okay, you guys, what we're going to learn today is something called implicit differentiation. So taking a derivative implicitly as opposed to explicitly. So just in case you're curious, you're like, what? In order, we've always been doing things explicitly, meaning my y is by itself. It's been nice because what's the derivative of, say, y equals 5x to the 4th? How would we say that? 20x to the 3rd. What would this be on the left-hand side? What's the derivative of y? What's a way that we could write it? Y prime. Give me another way. dy dx, okay? The derivative of y, do you guys feel comfortable, is dy dx. That's nice. We've been doing that the whole time. An implicit equation would be like, what is, could I say that this is equivalent to 5y over x equals 4. You guys, an implicit equation is when my y is not by itself. Okay? Implicit is when my y is not by itself. Oh. I'm going to just put that here. Y is not by itself. Y is not by itself. Boop. Okay, so I just want to take a sec. Which one is my y by itself Or would it be pretty easy to get my y by itself? So it said, which of the following could be written explicitly? So could I get my y by itself pretty easily? Let's talk about this one. Could I get my y by itself pretty easily here?
No.
Well, let's go back to algebra. What do we do to get y by itself here? So we got y cubed is 8 minus x squared. And then I could do the cube root, right? I got my y by itself pretty easily. So I got my y by itself. Could that be the same as 8 minus x squared to the third? Are those equivalent? And then, are you guys okay with taking that derivative? Yeah, so you guys could take that derivative. Should we practice it? Let's practice it because it's a chain rule. The derivative of y is dy dx or y prime, doesn't matter. What would be the derivative of this guy? What's my outer? Yeah, take the derivative of that outer. Leave that inner. I've just eaten the candy shell and I left the chocolate. I need to multiply that by the derivative of the inner. What am I multiplying that by?
2x.
Negative 2x. So that one's explicit. We can say, all right, this one I can write explicitly. Okay? Could I get this y by itself pretty easily? Yeah. So on this one, what would we have? Y equals,
25 over x.
yeah. Just as a reminder, what rule would I have to do if I took that derivative? I would have to use quotient rule unless, how could I rewrite this? 25x to the negative first. Are those equivalent? Okay. Is this going to be much easier doing this route now instead of quotient rule? Instead of low d high minus high low over low low, what would this derivative be? Negative 25x to the negative second. We're done. As opposed to low d high minus high d low all over low low, we're going to get the same answer. So when we can rewrite it, I do suggest it. What about this guy? Can we get my y by itself pretty easily? I got two y's, right? So this is going to require implicit differentiation, which when you don't know what it is yet, we're going to get there. What about getting this y by itself?
Yes.
How many y's do I have? Good. Not easy to get it by itself when I got two of them, right? Ugh. So that one's not explicit, my bad. Could I get a y by itself over here? Got two of them, but could I factor one out? Like this one I can't because this is my angle. I can't get this y, factor that out. But on this one, couldn't I have x minus 3 equals 12x? Y equals 12x over x minus 3? So this one I'd say we could write explicitly because we can factor my y out. This one I cannot since it's that angle. Ooh, back to algebra 2 and pre-calc. Could I get this y by itself? Yeah. Remember how?
Natural log.
It's true. We have a natural log, so the opposite of that one, opposite, E. Could I E both sides? This is why we do it as a little reminder. Those cancel out, and I'm left with E to the x squared minus 3x. So now that one can be explicit as well, that we can get my y by itself. Whew. Here we go. We got this. So I said, find the derivative of the following. These are explicit, so this is like what we've been doing. Let's do it. What would the derivative of this one be? Let's write dy dx as opposed to y prime, just so we can get used to a variety of things. Derivative of this guy would be
Negative 18x to the negative 7.
done. Derivative of this guy. If you left it like that, we've got to go quotient rule. Could I rewrite it a different way? Is that the same as negative 1/3 x to the third? Yeah. Then can I just use my nice little power rule? What would the derivative of this guy be? Negative 3 times a third is going to get me 1 x to the... Yeah, would you rather do that? Or would you rather go quotient rule? I think my little power rule is going to save us some time. I said, what happens when the equation is written implicitly? What's the derivative of y every time. Every single derivative right here. What do we say the derivative of y was?
dy dx.
Every time. Okay, you guys. So we got to say dy dx. Every time we've got a y, no matter if it's in the middle of an equation or not. You're like, what are you talking about? Let me give you an example right here. Determine dy dx. Here we go, people. Don't worry about these points over here. It says this is an equation. Does anyone know what shape this equation is going to look like when I graph it? I just heard a triangle. What? What? X squared plus y squared equals 25. Anyone?
V.
A circle. Oh my gosh, you guys, it's a circle. So what are they asking for when they say find dy dx? Dy dx is just the slope. Very good. You guys, if I ask for the slope at 0, 5, what do you think it's going to be? 0. What do you think the slope's going to be at 3, -4-ish? Negative, I think -1 sounds like a great. What about -5, 0? Undefined, right? Okay. First, we got to go figure out what is the derivative or what is that slope. What the heck? We've never seen an equation where the y isn't by itself. We do the exact same thing. But y'all might, let's just see how we do. What's the derivative of x squared? 2x. Okay. What's the derivative? We've only had a y before. What's the derivative of 2y? What's the derivative of y squared? Is 2y, just like it's an x, right? You know what I'm saying? X squared, the derivative of x squared is 2x. The derivative of y squared is a 2y. Here's where you're going to revolt. You can get your spears ready. You're going to revolt. Because what's the derivative of y?
X.
Y prime, which is another way we can write it. And you're like, excuse me? What are you talking about? Let me talk you through what the heck I just did here. We're doing chain rule out the wazoo. When we take a derivative of x squared, we're technically doing the chain rule every time. Let me give you an example. You are good with this. You're like, cool, it's 2x. What actually, this is my outer, this is my inner. Check this out. You don't need to write this down. This is just a little explanation. You're like, all right, the derivative of the outer, leave the inner. And then I'd have to multiply it by the derivative of the inner. What's the derivative of x? 1, agreed. Is it technically dx dx? And it is. And you're like, what? I've never seen that before. I agree, because it's just 1. Isn't anything over itself just 1?
Can you explain what that means?
Yeah, totally. So anytime that we're seeing like, hey, go take the derivative of 5x squared plus 4, whatever, 4, well, that's a 4. Boom. This is just saying take the derivative of my function with respect to that variable, meaning I'm going to have all x's. I've got to take it with respect to that variable. So when I take the derivative of x, you're saying, all right, I'm letting you know I took the derivative of x, and how we say that in calculus now is dx, like derivative of x, with respect to x. Look what they said. Determine the derivative, and it's always going to be with respect to x, okay, you guys? So they're saying take the derivative of this function with respect to x. So this, you are never, ever going to have to write it. I just wanted you to see it. Because we're always taking it with respect to x, this will always, the chain rule will always give me an extra 1 here, which multiplying by 1 doesn't do anything. But when I take the derivative of my y squared, and this has an outer of 2 and an inner of a y, we're still saying 2y, but I've got to go take the derivative of the inner. What's the derivative of y? What have we been doing with the derivative of y every single time? dy dx, bless you. So that is so easy to forget. But anytime we're seeing a y, we've got to put a dy dx. And I want you to remember, you've been doing that every time already. It's just been easier to see because the y has been by itself. You're like, oh yeah, the derivative of y, dy dx is, and this is kind of what we've been focusing on, the derivative of y has got to always have a dy dx with it. Whew. Okay, I don't expect us to be like, yeah, I'm ready to do that every single time, but I do want us to finish this question, and we'll just keep practicing, you guys. What is the derivative of 25? 0. It says determine dy dx. Can I go get dy dx by itself? Yeah, can I just subtract my 2x? And can we divide by 2? Y? Can we divide by 2y? dy dx is negative 2x over 2y, what would my dy dx be? So close. You got it. That is the slope of my circle at any single point on my circle. Dy dx just means slope. That is the slope of my circle at any point. And look what I asked. What's the slope at this point? 0, 5. So let's go ahead and write this. The dy dx at 0, 5. Again, there's that little evaluation bar. I need to go put in a 0 for x and a 5 for y into my slope. So do you agree to have a negative 0 over 5 as plugging in my x and my y? Negative 0 over 5, what would we say that simplifies to be? 0. And as we look at my graph of my circle, did we predict that at 0, 5, the slope would be 0? I dig it. At 3, 4, we said it'd be a negative 1-ish.
It's 3 and negative 4.
Oh, thanks. That's going to change it. 3, negative 4. 3, negative 4. What do we think my slope's going to be?
1.
Positive 1-ish, maybe? Let's see. Positive 3, negative 4 has to go right here. Positive 3, so do you agree? If I say, all right, I got to go find my slope now at 3, negative 4, my x would still be a negative 3, right? As I plug in a 3 here, it would turn into negative 3 over, yeah, what's a negative over negative? Positive. Do you think 3/4 is pretty close to our guess of positive 1? Feel great about it. And then our last one, we got to go find the slope, dy dx, at the point negative 5, 0. What would that turn into when I plug in negative 5 and 0 into my x and y? Negative 5 in for x would get me a 5 over 0. Anytime we're dividing by 0, undefined, that makes me think of vux. At negative 5, 0, do I have a vertical line? Do I have an undefined slope? Yeah. So the takeaway from this is life has been so good when y has been by itself. Our y is no longer always going to be by itself. Most of the time it will be, but when it's not by itself, you take the derivative of it like normal. You're like, cool, the derivative of y squared is 2y. We got to multiply by the derivative of y, which is dy dx. Let's just practice a couple off to the side. What if I said, hey, we got 6y to the third. What's the derivative of that? Whoops. 18y squared times, say that again? dy dx. You got it. What if I had a plus 9x squared following that? Just plus 18x. It's just the y's that we got to worry about. We always have to follow it with the dy dx. Here I want to start with this one before the other one. Do you agree? This is written implicitly because I got a couple of y's. This is my angle. I can't factor that out. So we got to go take the derivative of this one at a time. Bless you. Derivative of cosine. We got this. Negative sign. Leave the angle times the derivative of the inner. The derivative of y every time, dy dx. Whew. The derivative of 3x. 3. The derivative of 3y. 3. Very good, you guys. Whew. It's a lot. It's a lot. Every derivative of a y has to follow with the dy dx every time. Everything else, you just leave it like it's been a normal variable, but we do need to multiply it by the derivative of y, which is dy dx, because of the chain rule. Now, they're saying, hey, go find me dy dx. We need to get dy dx by itself. What the heck? Do you think I should bring this thing over just so it's on the same side as that dy dx? This is just some algebra now. So are we cool with moving this 3 over? So I've got negative 3, and then adding this quantity over. So we've got negative 3 equals 3 dy dx plus sine of y dy dx. You okay with the algebra that I just did there? I moved that guy to the left, and then I'm adding all of this. Because it's all being multiplied, I got to bring all that over. How would I get my dy dx? Just have one dy dx over here. Factor it out. Since they both have a dy dx, let's go say, all right, let's take it out. If I factor out a dy dx, what's left? Thanks, dude. He's saying 3 plus the sine of y If I distributed that, that's what I would get, what I started with, equals -3. And now we got to just divide by that quantity. And my dy dx final answer, -3 over 3 plus the sine of y. Okay, you guys, here we go. If the tangent of y plus x squared plus 9 equals 0, find dy dx. We got this. What's the derivative of tangent? Secant squared. Secant squared of my angle times the derivative of my angle. Very good, you guys, dy dx. Because there was a y. Anytime you got a y and we're taking a derivative, we need a dy dx. Derivative of x cubed?
3x squared.
3x squared. Derivative of 9. Careful. 0. Derivative of 0. Here's my derivative. They said, hey, go find that derivative when y is negative pi over 4. So I can go plug this in here. But what am I going to plug in here?
The x value at
The x value when y is negative pi over 4, right? We got to go find it. We got to go find that x value. So if x is negative pi over 4, let's go find, if y is negative pi over 4, I'm going to go plug that in off to the side so that I can figure out what my x is. So I'd have the tangent at negative pi over 4 plus x cubed plus 9 equals 0. Okay. Can anyone think unit circle, tangent at negative pi? Okay, so from the unit circle, we know this value here is going to get me a -1 plus x cubed plus 9 equals 0. Let's go solve for that. Oh, guys, that's a 9. Here we go. X cubed plus 8 equals 0. Can x cubed equal -8? This is kind of what Ellie and I were talking about on Thursday. Can a cube root be negative? Can I take the cube root of -8? Square root, fourth root, I agree I cannot. But let's try math 5 cube root of -8. Why is it -2? Because there's 3 of them. -2 times -2 is 4 times -2 would get me -8. So whenever it's an odd exponent, I can take the root of a negative. Even exponents, I agree, I cannot. AP is not going to want any imaginary numbers, but this one does work out. So when y is negative pi over 4, my x was -2. So now we know that my function includes this point. And now I can go plug in a -2 for my x. Whew. Okay. Let's say the secant squared of negative pi over 4. Ooh, I got a dy dx still. I didn't solve for it yet, and I did that on purpose just to show you we don't have to get my dy dx by itself first if you don't want to. I'm going to go plug in a -2 for my x. This right here, I'm going to rewrite just to give people some time to get caught up if they needed it. This is really secant of negative pi over 4 squared. This is go find that secant at pi over 4, then square the whole thing. So I'll just bring this down. Okay. Pi over 4. It goes pi over 6, pi over 4, pi over 3. So at pi over 4, what's the cosine there? Root 2 over 2. Therefore, what's the secant? Just flip it. Don't do any math. Just flip it. 2 over root 2. That's a great way to do it. Then we can square it. Which we are used to simplifying it. You just don't have to. Right? We don't have to simplify it. So I just want you to go find its cofunction, which is cosine, at that point. Oh, I didn't realize that it was at negative pi over 4. Is it the same thing?
Yeah.
Exactly. Perfect, because it's still the x coordinate. Okay, then we still have that multiplied by a dy dx. Plus, what's this going to get me? Yeah, we got to square this first. -2 times -2 is 4, times 3 is 12. Now let's go solve for that dy dx. What's this going to do? 2 squared. 4 on the top, root 2 squared on the bottom is a 2. So that's just going to get me a 2. Agreed. Oops. dy dx equals a negative 12. So what's my slope at that point? Negative 6.